Hello and welcome back to yet another solution video of paper 32 of A-level mathematics pure math 3 October-November 2022. If you like this video, please share with your friends and subscribe to my channel. This will motivate me to make many more videos in coming days. Question number 1. Solve this exponential equation. Give your answer in this format. The format we'll worry about later. Let's look at this. So here we can see that it's 2 to the power something. Here it is 3 to the power something. So the bases are not same. So we cannot club them. So it's better to use logarithm for both. We can use natural log because they're saying natural log in our format. So let's use natural log for both of them. So I will apply natural log in front of the left side, which is len 2 to the power 3x minus 1, and also len. So please, I'm writing len in front of the whole of this and whole of this. I cannot write len in between 5 len something. No. So we have to write 5 here and they will be together inside natural log. 3 to the power 1 minus x. So I have applied it to both of them. Okay. So by logarithmic rules, this 3x minus 1, which is a component, becomes the coefficient. So 3x minus 1 len 2, and 3x minus 1 is in bracket. That means whole of it is multiplying, not only minus 1. Even 3x is multiplying, so we have to put a bracket here. Equal to. Now we cannot bring this 1 minus x and make a coefficient because this 5 has to go first. That rule is only for a pure natural log, which was here. This is not a pure natural log. This 5 has to go. So for removing it, we will separate len 5 plus len 3 to the power 1 minus x. Now they are separated, and because they were multiplying inside, outside the natural logs add up. Okay, so 3x minus 1 natural log 2 equal to natural log 5 plus, now it will come in front and we'll be left with natural log of 3. What is the purpose? Solve the equation means find the value of x. That means this x here and this x, they have to be combined so that they become 1x. So how can we do that? We will open the brackets. 3x multiplied by len 2. 3x len 2. Okay, I'm not writing bracket anymore. Minus 1 times len 2 equal to len 5 plus, and this 1 will multiply with len 3, just len 3, minus the x will multiply with len 3, brackets opened. Now we will combine this x and this x by bringing them together first. So 3x len 2 and this len 2, 5 and 3 will be together. So I will write plus x len 3 first, and now len 5 plus natural log of 3, and this was negative here, will become positive natural log of 2. And now we have x on same side, we will take it common to isolate, and we will be left with what? 3 len 2 plus x is already out, so len 3 only, equal to, there are 3 natural logs which are adding, so when they add, their contents multiply. Just like here, they were multiplying and we separated them to make it addition. Now they're adding, we will make them 1 by multiplying inside. 5 times 3 times 2. Now this 3 will become an exponent of 2, so x len 2 cube plus len 3 equal to len 5 times 3 is 15 times 2 is 30. Okay, x, they are also adding, so they will also multiply inside the natural log. So 2 cube is 8 times 3 equal to natural log of 30. Let's complete it here. So x remains x. We have inside len 24 now equal to natural log of 30. Let's divide both sides by ln 24 so that this x is isolated. Okay, here they cancel, and finally we get x equal to ln 30 over ln 24, and we don't have any logarithmic law for division of natural logs or any logs, so we'll leave our answer like this. So it is in the format they wanted. A is 30, B is 24. And let's move on to the question number 2, A part. The polynomial 2x cubed minus x squared plus a, where a is a constant, is denoted by px. All right. It is given that 2x plus 3 is a complete factor of px. Whenever a binomial is a factor of a polynomial, we make it equal to 0 first to convert it to root. So 2x plus 3 is 0, and that means 2x equal to negative 3. So x is equal to negative 3 over 2. This is a root now. So if a factor is 0 and that factor is part of this polynomial, this whole polynomial will become 0. So by remainder theorem, let me write here, remainder theorem, if I substitute this root in the polynomial p, so in place of x we write minus 3 over 2, so it will become 2 minus 3 over 2 cube minus 3 over 2 square plus a, and that has to be 0 because the factor is 0. So the polynomial has to be equal to 0. So 2 times and 3 cube is 27, but because it's cubed, an odd exponent, this negative will remain negative. So minus 27 it will remain. 2 cube is 8 minus, but this even exponent here, so this will become positive 9 over 4, and because this negative was negative, so it will stay negative, plus a is equal to 0. This 2 and 8 may cancel, and we are left with what? This 4. Minus 27 over 4 minus 9 over 4 equal to negative a. I'm bringing this positive a to the right side, so it becomes negative 36 over 4 equal to negative a. Both of them are negative, so we can cancel out. 36 divided by 4 is 9. So a is 9, and that's what they asked us to find out. Okay. When a has this value, okay, solve the inequality. So let me make some space here. Okay. So a has this value, so let me write this with the value. So px now becomes 2x cube minus x square, and a is 9 now, plus 9. Okay. Solve the inequality. Px is less than 0. This is what we have to write. For solving the inequality, first we should factor this fully, and we know one of the factors was 2x plus 3. So let's carry out long division to find the other factors. So 2x cube minus x square plus 9, we will divide it by 2x plus 3. So first we should look for something which makes 2x cube, so x square is the one. If I multiply x square here with 2x, we get 2x cube, and x square multiplied with 3 gives us positive 3x square. Now we will subtract, so this cancels out, and this becomes minus x square minus 3x square is minus 4x square. This positive becomes negative, and plus 9. Now we need 2x to become minus 4x square, so we'll have to multiply by minus 2x minus 4x square, and 3 multiplies with minus 2x gives us minus 6x. Let me write it here. We'll subtract again. This becomes positive because of subtraction. This also becomes positive. So this cancels. We are left with 6x plus 9, right? This is positive 6x. This is 9. 6x plus 9. Now, 2x multiplied by 3 will give us 6x. So 6x and 3 times 3 is 9. And yeah, we were right. Everything cancels out. We get an exponent 0. So this is our new factored polynomial, and let me write it here. It will be 2x minus 3, which was already 2x plus 3 rather. 2x plus 3 and x square minus 2x plus 3. This becomes our new inequality. Okay, so now we have to factor this to get more roots. So x square minus 2x plus 3. So this 1 we get a, minus 2 we get b and c. So minus 2, I'm using quadratic formula, okay, plus minus square root b square minus 2 square minus 4ac over 2 times 1. And if we look at this discriminant, this one, you can see here this is 4, positive 4 minus 12. 4 minus 12 is negative 8. Inside this square root, the discriminant part is negative. That means this has no solution, no roots from this. So this is the only one. Now, we want less than 0. Less than 0 means negative. Yeah, less than 0 means negative. Yeah, anything which is less than 0 is negative. That means the multiplication of two parts is negative. When is it possible that two parts multiplying will be negative? If this is positive and this negative, then it will be less than 0. Or this is negative, this is positive, then their multiplication will be less than 0. Yeah, negative, then it will be negative. But let's see, if there is no root, that means the graph of this particular part, x square minus 2x plus 3, will be either this way or this way. Yeah, either it's positive or negative. Let's see. So what can we do? We can look at the leading coefficient. Leading coefficient of x square is positive. Can you see a positive? Whenever it is positive, it opens up and goes endlessly upwards. So it cannot be below x-axis. That means the graph is always positive. Yeah, because the leading coefficient is positive of this factor. So this is the case. This is the case. That means 2x plus 3 is negative. Then only negative times positive will be less than 0 negative. So we'll do this, we are sure. 2x plus 3 is negative. That means 2x is less than minus 3. And if I divide both sides by positive 2, no change in sign. 2 and 2 cancel. X is less than negative 3 over 2. This is the solution of this inequality. Okay. Question number 3. The equation of a curve is this. The curve has a stationary point, okay, in the interval from 0 to half pi, that is 90 degrees. Find the x coordinate of this point, giving your answer correct of 3 segment figures. For stationary point, what should we do? We should always make dy over dx equal to 0, because stationary point is what? When the curve is turning back. And if we draw a tangent on this, it's a horizontal line, and the gradient of tangent is nothing but dy over dx, and this gradient of this line is 0. That's why we make it equal to 0. So first we have to differentiate y equal to sin x 2x, sin x sin 2x, and then we'll make it equal to 0. So let's find dy over dx first. Since two parts are multiplying, we will use product rule, which is sin x prime, differentiate this one, but do not differentiate sin 2x. In second part, sin x will be untouched, but sin 2x will be differentiated, and that has to be equal to 0. So differentiation of sin x is cos x sine 2x plus sine x, and the differentiation of sine 2x will be 2, I'm writing 2 here, cos 2x. So we first differentiate sine 2x, which is cos 2x, and further we multiply by the differentiation of the angle, which is chain rule. So 2 I'm writing in front, which is equal to 0. If this 2 was not there, this 2, then it would be simply sine x plus 2x, right? Sine 3x. But this 2 is there, that means we'll have to make some changes. So we'll open sine 2x first. So cos x remains cos x, and sine 2x is 2 sine x cos x. So we're getting cos square x here. So let's choose cos square x here also, because cos 2x has 3 options. Cos square x minus sine square x. We don't want minus sine square x because we have just sine x here. And second option is 1 minus 2 sine square x. We don't want this, we want cos square x. And third option is 2 cos square x minus 1. These are the 3 options of cos 2x, and I will choose this one. Why? Because we have a cos x times cos x, cos square x in the second one also. So it will become 2 sine x remains 2 sine x, and cos 2x will be replaced by this, which is 2 cos square x minus 1. Okay, so 2 cos square x sine x plus 2 sine x, not 2, 4 now, because this 2 times 2 will be 4 sine x cos square x minus 2 sine x equal to 0, Okay, so they are exactly same, both of them, so they'll become 6 cos square x sine x minus 2 sine x equal to 0. Sine x is common in both, so let's take that sine x common. What are left? 6 cos square x, and here we are left with just minus 2 sin x equal to 0. Okay, so now this gives us one answer, which is sin x equal to 0, and from 0 to pi by 2 x equal to 0 is the answer, but it is not part. If you look, there is no equal sign here. There is no equal sign. That means this answer will be rejected. This is not part of our answer. This will be the one which will give us answer. 6 cos square x is equal to 2. Yeah, if I say minus 2 equal to 0, so 2 goes there. Divide both sides by 6. So cos square x equal to 1 over 3. And let's complete it here. Square root both sides. So cos x equal to plus and minus 1 over square root 3. Yeah, square root of 1 over square root 3. But since it is from 0 to half pi, which is 90 degree, that means cos negative will not be there. So only positive will be taken, because in first quadrant, of our angle here, all the ratios sine cos tan are positive. Cos is positive here, so we'll take this. So x becomes cos inverse 1 over square root 3. By the time I use my calculator, I will request you to like this video, share with your friends, and subscribe to my channel to motivate me to make many more videos like this. What I'm getting here is 0.9553. So I will write 0.955. Only this is the x coordinate. They said find x coordinate of this point, giving your answer in 3 single figures. That's what I've done here. This is the answer. Alrighty, question number 4 is this. Okay, express 4 cos x minus sin x in form of this, where r is positive, yes, and it is alpha is between 0 and 90 degrees. So we'll have to set our calculators to degrees now, state the exact value of r, and there is a shortcut for this, but I will give you the detailed method of the way it is done. So let me write that one first. 4 cos x minus sine x, right? Let me open this one. R remains R outside. Cos a plus b. What is the, look at your formula sheet. Cos a plus b is cos a, cos b, minus sine a, sine b. So in place of a and b, I have written x and alpha, right? Like this. So now if I open this, it becomes what? R cos x, cos alpha, minus r sine x, sine alpha. Now look at this. This 4 can be written as r cos alpha, because cos x is here, cos x is here. That means 4. I can write r cos alpha is 4. That's my equation number 1 by comparison with this. Second, if I compare with this, sine x is here, sine x is there, minus is here, minus is there. So that means r sine alpha will be the remaining part. There is nothing remaining here, which is 1. Yeah. So now this becomes equation number 2. They said find the exact value of r. To find the exact value of r, let's square equation 1 and 2 and add them. What it means? Square r cos alpha, it becomes r square cos square alpha, and square the right side also, because we can't square only one side, we have to square the other side also, right? And then I will square this one also. It becomes r square sine square alpha equal to 1 square, which is 1, and add them. Yeah. So can I write r square is in both of them? I can write cos square alpha plus sine square alpha equal to 17, isn't it? And we know this is 1. So r square is equal to 17, square root both sides, r equal to plus minus square root 17. But clearly they have seen here, they have already stated here, r is greater than 0, positive. That means this negative has to be ignored. So r is equal to positive square root 17. We got the exact value of r. Now they are asking alpha correct to 2 decimal places. That's what we need to do. For doing that, what will we do? We'll divide equation 1, so equation 2 divided by equation 1. Why 2 by 1? Because we know that sine divided by cos is 10, and that's why we'll do that. So r sine alpha divided by r cos alpha, which is the left side divided by left side, will be 1 divided by 4. R and R cancel, that was the purpose. And sine alpha over cos alpha is tan alpha, which is 1/4. Alpha is tan inverse 1/4, and we need in first quadrant only 0 to 90 degrees. So let me use my calculator in this case and get the answer. The answer is inverse 1/4. Alpha comes out to be 14.04 degrees to 2 decimal places. That's what I'm getting. Actually it is 14.036, but rounded off to 14.04. Let's look at the second part of this question, which is hence solve this equation. 4 cos 2x minus sine 2x equal to 3. Let's compare it with the a part, because they're saying hence we have to take the help of a part. So 4 cos x, 4 cos 2x, that means angle has changed to 2x. minus sine x minus sine 2x equal to 3. That means this was our format, right? R cos alpha, this one. So we can, let me write it here. In place of this, I can write R, we got square root 17. This is B part I'm doing here. Square root 17 and then cos x plus alpha. Alpha we got 14.04 is equal to 3. But x is not x. X is 2x in this case now. That means we have to replace x by 2x here. And this becomes our new equation. So we'll solve this by first divide both sides by square root 17. So it cancels here. So 2x plus 14.04 becomes cos inverse 3 over square root 17, and our angles are from 0 to 180, right? But whenever we have a coefficient in front of x, is 2x, that means it will reduce the angle. That means we should go beyond our boundaries. So we can cross 180 for original solution and then we'll get the answer within our boundaries. What I mean is this. Let me try the first one. Cos inverse 2 over square root 7. Let me take the first angle. I will not go beyond 0 degrees, means into negative zone. Why? Because, okay, let me see. Let me show you why I'm not going into the negative zone. Suppose I get negative 15. Okay, so 2x plus 14. I'm just giving an example, equal to negative 15. So this plus 14 will go there, becomes negative. So negative and negative will be negative, divided by 2 will give you a negative angle which is less than 0. So taking a negative angle is not a wise idea. Otherwise, sometimes we have to go to negatives also. Okay, especially when this 14.40, if it was positive here, sorry, it is positive right now, but if it was negative there, then we could have gone into the negative zone. But no, we will not. We will go only in the positive zone. Let's talk about the first quadrant here, because cos is positive here, right? And cos is positive in fourth quadrant. These two we will try first. First answer, cos inverse 3 over square root 17. So we got our first answer. 2x plus 14.04 is 43.313. So 43.31. So 2x equal to 43.31 minus 14.04. 2x equal to how much? 29.27. Yeah. And divide both sides by 2. So we get x equal to, have they given how many decimal places? No. So we'll put into one decimal place. So it will be 14.685. Yeah. So let's say 7. 14.7 degrees is the first answer. Let's go to the second one, which is this angle from here and here till here. And this angle is how much we got? 43.31. 43.31 is this angle. That means it is not complete 360. It is 43.31 lesser. So 2x plus 14.04, which was our original angle, here will be equal to 360 minus 43.31. Okay, so 2x equal to 360 minus 43.31 minus 14.04. Divide by 2, divide this whole thing by 2, we will get our second answer. What I'm getting is 151.325. So I will adjust 3. This is the second angle. Now, since this is 2, I told you this 2 will halve every angle. So we should go beyond the boundaries now. What we will do, I will go to this angle now. This was 43.31, this one. Second angle we got this 360 minus 43.31. I'm going to the third one, which is 360 plus 43.31. Because this 2 will bring back me up to 180. That's what my expectation is. So let me try to do that. So next answer will be 2x plus 14.04 equal to 360 plus 43.31. So 2x equal to 360 plus 43.31 minus 14.04 and divide by 2 both sides again, which comes out to be 194.635, much more than 180. So no, this was not needed. These two are the only answers. Moving on to the next one, which is this complex number. Okay, solve this quadratic equation giving the answers in form of x plus iy and x and y are real number. This is quadratic. This is quadratic, right? So the answer, that means the root of this one root is x plus iy. That's what they're saying. We have to give this format, right? Second root definitely going to be x minus iy. Why I think so? Because in our quadratic formula, if you remember, it is plus minus b square minus 4ac over 2a. This plus minus, because in case of complex number roots, this is undefined. It is square root of a negative number, and that's why we get i's. And this plus minus will ensure that one of them is plus, one of them is minus. And what I'm going to do now, that I'm assuming that z minus first root times z minus second root is equal to z square minus 6iz minus 12. Let's focus on the left hand side. So if I open it, z minus x minus iy and z minus x plus iy. I will expand this and I will compare it with the right hand side later on. Okay, so z times z is z square, z times minus x z, z times iy will be plus I z y. Now minus x times z will be minus x z. Minus x times minus x is x square. Minus x times iy will be minus I x y. Minus iy times z is minus I y z. Minus iy times minus x is minus, rather positive, I x y. Minus iy times positive iy will be minus I square y square. Okay, we can see this and this are exactly same with opposite signs. They cancel out. They don't. This cancels out with this one. So we are left with z square minus xz and xz, 2xz plus x square, and then this is minus 1, right? I square is negative 1, so negative 1 times negative 1 will be positive 1 y square. And now we'll bring in the right hand side, which was z square minus 6iz minus 12. Now let's compare. Z square and z square are same, so we can keep them away. Let's compare the constant part. These are constant, right? A and B are constants. They are equal to minus 12. So x square plus y square equal to negative 12. That's our one equation. Second, minus 2xz equal to negative 6iz. Let's divide both sides by minus 2z and minus 2z here. So minus 2 and z cancel. We are left with only x here, and this becomes positive. 3 divided by 2, 6 divided by 2 is 3i. X comes out to be 3i, but they said x and y are real and exact. Don't worry about this. We will substitute and we'll get the right ones later. So let's substitute it here. 3i square plus y square equal to negative 12. I square is negative 1 and 3 square is 9. So negative 9 plus y square equal to negative 12. Y square is equal to negative 12 plus 9. Y square equal to negative 3. And if I square root both sides, I get y equal to plus and minus. And this is negative, square root of negative 1 will be I. And square root of 3 will be square root 3i. So now we will put here x plus iy. This was the format we needed, right? X came out to be 3i. Iy will be I times square root plus and minus square root 3i. So we get 3i, and this I will give us negative. So again positive negative square root 3. So our two solutions are square root 3 plus 3i and negative square root 3 plus 3i, where x and y are real and exact. So we can get here. Now we can compare. So we'll compare this one. So x is square root 3 plus and minus, and y is 3. What next? On sketch of Argand diagram, show points A and B representing the roots of equation. Okay, so this is the imaginary, and let's say this one is real. Okay, so the points are, what are they? Let me go back to them. Square root 3 plus 3i. So this is 1, this is 2, this is 3. Square root 3 is 1.73. Somewhere here is square root 3, the real part, and there is 1 square root, negative square root 3 also. So 1, and let's say this is negative square root 3. This is positive square root 3. Okay, and plus 3i, the imaginary 3i. So 1, 2 and 3. So if I take a point from this is 3 in imaginary, and this is real axis. So the point will be here and here. So let's call this one A, let's call this one B. Okay, done. Find the exact modulus and argument of each root. That is the C part. So modulus and argument. Modulus will be same because we can see the distance from origin till B will be exactly same as from origin to A. Modulus of this will be square root 3 square plus 3i square. Okay, so it is 3 plus 9 square root 12, and for A it will be negative square root 3 square plus 3 square, which is exactly same, right? So square root 12 and square root 12 is the modulus, exact modulus and argument of each root. Okay. What about argument? Arguments will be different. Argument of, let's say, a. So argument of a will be from here till here. This is a. So if I complete this triangle downwards and find this angle, let's call this angle alpha. So tan alpha, let me do it somewhere else. Tan alpha will be opposite. What is opposite to square root 3? So 3, complete 3. This is 3, yeah. The side opposite to alpha is 3. So 3 divided by adjacent, which is square root 3. I'm not writing negative because I'm interested in this distance, this particular length, not the sign. So which is square root 3. So alpha is tan inverse square root 3, and which is tan inverse square root 3 is pi by 3, 60 degrees, pi by 3. So argument of a will be, this is pi, yeah, from 0. If we start from this half line till this line is pi, but it is alpha lesser than pi. So pi minus pi by 3 will be the argument of a, which is 2 pi by 3. What about argument of b, which is just this angle from here to here, which is, we already know, pi by 3. The same, if I complete this same triangle, it will be the same angle again. So pi by 3 straight away. No subtraction, no addition required. So C part is also done. What about the next one? Hence, show that the triangle OAB is equilateral. Okay, we can easily do that by finding this distance. This is square root 12, this is square root 12. If this distance also comes out to be square root 12, it will be an equilateral triangle. But they have used the word hence. Hence means we have to use modulus. We can't use the distance formula. All right. So we have to prove that the third angle, because this angle is alternate to this angle, correct? This is pi by 3. This is pi. This came out to be pi by 3. So this is also pi by 3. So just show that this angle is also pi by 3, and we get, because each angle of an equilateral triangle is pi by 3, 60 degrees. That's why it's an equilateral triangle. So argument of A minus argument of B is equal to angle AOB. So argument of A is 2 pi by 3 minus argument of B is pi by 3 is equal to angle AOB, and 2 pi by 3 minus pi by 3 is pi by 3, angle AOB. So we can see that all angles of the triangle AOB, or they're saying OAB, so let's use the same notation. OAB equal to pi by 3, triangle OAB is an equilateral triangle. Okay, what about the next question? Relative to origin O, the points A, B and C have position vectors these. Okay, using scalar product, find the cosine of the angle BAC. Let's draw them first. Okay, let me draw them randomly. I'm not drawing them to the scale. So the first position vector of A is 1, 3, 1. So the coordinates of this become 1, 3, 1. This is A. B is 3, 1, 2, and C are 5, 3, minus 2. They want the cosine of the angle BAC. BAC, that means this angle, right? Keep in mind, the angles are always tail to tail or head to head. Let me make it tail to tail. That means this vector and this vector I'll find out. So we want angle BAC, right? Cosine of angle BAC. So we have to use this vector first, AB. dot AC will be modulus of AB multiplied by modulus of AC cosine of BAC angle. Yeah, this is what it will be, and this is what we have to find out. So let's find AB dot AC, that means the dot product of vector AB and AC. Let's find first the vector AB, which will be position vector of B minus position vector of A. So what do we have here? 3, 1, 2 minus 1, 3, 1. So it will be 3 minus 1 is 2, 1 minus 3 is minus 2, 2 minus 1 is 1. What is the modulus? We need modulus also, right? So magnitude of AB will be square root 2 square, this one, plus minus 2 square plus 1 square, which is 2 square is 4 plus 4 plus 1, 9, 3. 3 is the magnitude of AB. Similarly, magnitude of AC. First we have to find AC. Will be OC minus OA. OC 5, 3 minus 2 minus 1, 3, 1. 5 minus 1 is 4. 3 minus 3 is 0, and minus 2 minus 1 is minus 3. So it will be 4 square plus negative 3 square, which is 16 plus 9, 25, 5. 5 is the magnitude of AC. We got this is AC, this is its magnitude, and now we'll substitute everything in this and we'll get our angle. Alright, first AB dot AC. AB is 2 minus 2, 1. Dot AC 4, 0 minus 3 equal to magnitude of AB is 3 multiplied by magnitude of AC cosine of BAC. So dot product, in dot product x component multiplies with x component, so 2 times 4 is 8, minus 2 times 0 is 0, 1 times minus 3 is negative 3, equal to 15 cos BAC. So 8, let's complete here. 8 minus 3 is 5, equal to 15 cos BAC. Divide both sides by 15 and it becomes 1 over 3. 1 over 3 cos of BAC is 1 over 3. That's what they wanted. Using scalar product, find the cosine of angle BAC. This is the cosine of angle BAC. Alright, hence find the area of the triangle ABC. Triangle ABC, the same angle. We have to find the area of this triangle. So to find the area of a triangle, we have a formula, right? So area of a triangle. Since we know cos of that angle, we have to use that angle. So we can say that half AB sine C, where C is the angle between A and B, right? This angle BAC is between this side and this side. We know the magnitude of them, which is 3 and 5. So it becomes half 3 times 5. But the problem is we know cos, we don't know sine, but we know, let me do it here. Don't we know that sine square A plus cos square A equal to 1? Can I say sine square A equal to 1 minus cos square A? Yeah. And since we need sine, can I square root this? So to get rid of this square root and square root this also. And that's what I'm going to do. Sine A is equal to square root, this and this cancel, okay? Sine A is equal to square root of 1 minus cos square A. That's what I'm going to do here. Square root 1 minus cos. Cos is this 1 over 3. So 1 over 3 square. So because of this word hence, I used cos. And now we can do is, it's become 15 over 2 and multiply 1 minus 1 over 9, which is 15 over 2 and square root 8 over 9. And we want simplified exact form, right? Simplified exact form. So square root 9 is 3, we know that. So let me write here 15 over 2 times square root 9 is 3 and square root 8 can be written as 2 square root 2. I hope you understand how. Because square root 8 is square root 4 times square root 2. Square root 4 is 2. So that's why it is 2 square root 2. 2 and 2 cancel here. 3 cancels with 15. So the final answer is 5 square root 2 units square. That is the area of the given triangle. Let's move on to the next question, number 7. Okay. Variables x and theta satisfy differential equation this. Okay, x is between 0 and half pi, x is greater than 0. X is between 0 and half pi, x is greater than 0. It is given that x is equal to when theta is this. Part A. Show that d over theta, differentiation of cot square theta with respect to theta is this. So it has nothing to do with this previous explanation, just differentiate. So cot square theta, we have to differentiate this. So to differentiate, first we will just treat it like an exponential expression. So 2 will come in front and its exponent will go down by 1. So square will become 1. But further, we will multiply it by the base, which is cot theta in this case. Differentiation of that base will multiply with. And they've already said derivative of cot theta is minus secant square theta. Yeah. So it will be 2 cot theta and minus cosecant square theta. This will be the answer, but they want us to show this. So 2 cot theta is 2 cot theta. We have to change cosecant square theta, and obviously cosecant square theta is 1 over sine square theta. So it becomes 2 cot theta as 2 cot theta. This minus will remain minus and divide by 1 over sine square. So sine square theta. We have shown this. Okay, solve the differential equation and find the value of x when theta is 1 over 6 pi. We'll look at this later. First, we'll solve this differential equation and x sine square theta. So x and dx, they are together. So let's leave it them here. X dx. Okay. Now this sine square theta will go to the other side and divide. Okay. And this d theta, which is the denominator here, becomes numerator. So let's make it numerator d theta here. And tan square theta minus 2 cot theta is already here. So let's write tan square theta minus 2 cot theta here. And this sine square theta becomes denominator. Sine square theta. Okay. So now x is with dx and theta is with theta, this theta. Okay. So x, let's write x dx again and separate them here. Tan theta divided by sine square theta minus 2 cot theta over sine square theta. Okay, d theta also, d theta and d theta. So we'll have to integrate both sides. x integration of x with respect to dx is x square over 2, and tan, okay, I forgot square here, it's got tan square theta, not tan theta. So this can be simplified. Sin tan square theta will be sine square theta over cos square theta, and we already have a denominator sine square theta, so we'll write sine square theta also. They cancel out, so we are left with 1 over cos square theta, which is secant square theta. That means this one can be written as secant square theta d theta, and minus 2 cot theta over sine square theta is already given to us. Can you see? D over d theta of cot square theta is minus 2 cot theta over sine square theta, exactly same, right? That means the integration of this will be cot square theta and positive. This is negative, that is positive. So we have to write positive here. Plus cot square theta plus c. Now we have to integrate this one. X square over 2 will be integration of secant square theta is just tan theta plus cot square theta plus c. Now next job is to find this c, and we will use the information they have given earlier. When x is equal to 2, theta is 1 over 4 pi. So when x is equal to 2, theta is 1 over 4 pi. So 2 square over 2 equal to tan 1 over 4 pi plus cot square 1 plus 1 over 4 pi plus c. So this 2 cancel with the square here, so 2 equal to tan 1 over 4 pi is 1, cot 1 over 4 pi is also 1, so 1 square is again 1, and plus c. So 1 plus 1 is 2, this 2 and this 2 cancel, c is 0. So our differential equation is solved as x square over 2 equal to tan theta plus cot square theta. That's it, no c anymore. Now the question was something else. Question was find x when theta is 1 over 6 pi, and that's what we're going to do now. So when theta is 1 over 6 pi, x square over 2 equal to tan 1 over 6 pi plus cot square 1 over 6 pi. So x square over 2 equal to 1 over 6 pi will be square root 3 over 3, and cot 1 over 6 pi will be the reciprocal of this, which is 3 over square root 3, or just write square root 3, and we have to square this also. So this square and square root cancel, so x square over 2 is equal to 3 plus square root 3 over 3. Are they saying exact value? Nope. So we'll multiply both sides by 2 now to get the value of x. So x square is equal to 6 plus 2 square root 3 over 3, and we have to square root both sides, plus and minus. Are they saying x? They said x is between 0 and 1 over pi, and x is positive, so negative we will not take, just this is the answer. Or you can use this, use your calculator to find the value of what we have here. So let me do this. By the time I do this, I would again request you to please subscribe to my channel, share this video with your friends, and like this video. This will motivate me to make many more videos like this. So this is the exact value, but if I use my calculator, I got x equal to 2.674. So 2.67 is the answer here. Okay, let's see what is stored for us in the next one. All right. Question number 8. The diagram shows part of a curve, this one sine square root x. This part of the curve intersects x-axis at point x equal to a. Yeah. State the exact value of a. So we can already see it is also intersecting at O, which is origin. So we have to find the a. That means one of the solutions will be of x-intercepts of this curve will be 0, but we'll ignore it. We have to find a. So let me use this space. Sine y equal to sine square root x. We have to find x-intercept, right? So for x-intercepts, y has to be equal to 0. Yeah, in this whole line y is 0. So we'll put y equal to 0. 0 equal to sine square root x. And we will find square root x is equal to sine inverse 0. And if we want to get rid of square root, square both sides. So x is equal to sine inverse 0 square. So now we know in sine graph it is something like this. This is 0. The next intersection is pi by pi, just pi. Yeah. So I can't take 0 because we already know this one. So we will say x is equal to pi square. All right. This is the exact value. This is the exact value. What about the next one? Using the substitution u equal to square root x, find the exact area of the shaded region in the first quadrant bounded by this part of the curve and x-axis. This part of the curve and x-axis, basically the shaded area we have to find out. So in other words, they're asking us to find the definite integral from 0 to pi square. Yeah, this is pi square now. And sine square root x dx. They said use substitution u equal to square root x. Let's do it. U equal to square root x. So it becomes, what is du over dx? The differentiation of square root x is 1 over 2 square root x. If you want explanation, let me tell you how. X to the power half, square root x can be written as this. Half comes in front, it becomes 1 over 2. And then this exponent goes down by 1. Half minus 1 is negative half, which I make it positive by bringing it down. That's why it is 1 over 2 square root x. So let's cross multiply this here. So dx equal to, and this 2 square root x will multiply with du. 2 square root x du. Square root x is u. We have, that's the substitution we have taken. So we can say 2u du is dx. But we need to change these limits also. So let's change them here. Using this, when x is 0, this 0, what will be u? So u will be square root of 0, which is 0. That means our lower limit remains 0. When x is pi square, u will be square root pi square. This cancels. So we get pi here. So now it becomes sine u, and then we have 2u du, not dx. 2u, let me write 2 outside, u here, and du. This is what we have to integrate, and this will give us the area under the curve. We have also changed the limits. Okay, so let's use integration by parts. So uv is equal to uv minus u prime v. Now confusion here is they have asked us to substitute u. This u will confuse with this, but Let's see. In our hierarchy, let the algebraic becomes u, so u is u. This trigonometric is v prime. Alright, so that is easy for us. So u v prime, this is u, this is v prime. V prime is sine u. So integrate both sides, we'll get v. So v will be negative cos x, cos u rather, negative cos u. And u is u, so u prime will be 1. Alright, so let's use it. uv prime will be equal to uv. U is u. 2 u. Okay, v is minus cos u. So I'll put minus here, cos u. Next is minus integration of u prime. U prime is 1. So no need to write 1. V is negative cos u. So I will write cos u here and make it positive du. Alright. So, and this 2 is with whole of it. 0 to pi. Okay. 2. And this is minus u cos u. Integration of cos u is sin u plus sin u. 0 to pi. Okay, so let's substitute now 0 and pi. So 2 remains outside. When I substitute pi first, so it will become minus pi cos pi plus sin pi minus okay, I didn't write plus c here, but for these different integrals c gets cancelled out, that's why it's not important. Minus 0 cos 0 plus sin 0. This is 0, this is 0, so ignore them. That means this 2 will multiply only with this one. So minus 2 pi. Cos pi is negative 1. Sin pi is 0. So 2 times 0 is 0, so no need. That is the answers. So negative 1 times negative 2 pi will be positive 2 pi. That is the area under the curve. Alright, question number 9. Let's use this space here. The diagram shows a semicircle, you can see here, with diameter AB diameters. That means OA, center is at O? Yeah, center is at O. So OA and OB are the radii R. And the shaded region is the minor segment with the chord AC, alright. And its area is 1/3 of the area of this whole semicircle. The angle CAB is theta radians. Show that theta is 1/3 blah blah blah. Okay, so let's use this particular sentence. They have written the region, the area of this shaded region is 1/3 of the area of the semicircle. Okay, how can I find the area of this shaded region? That's what I have to look for. Area of a semicircle is easy. So if I find the area of this sector, yes, and this triangle, if I find the area of this sector and this triangle and subtract from the whole semicircle, I'll find the area of the shaded region. So let me undo this one first. It will become untidy otherwise. Okay. So let's find the area of this triangle first. Area of triangle AOC will be half AB sine C. We used this formula in one of the previous questions, right? Where AB are two sides and C is the angle between them. So I'll take this AO as one side, and that AO is nothing but the radius R. I will take OC as the second side of the triangle, which is also R. and the angle between them is this. Now, how to find this angle? We know this is theta radians, this is r, this is r, that means this triangle is isosceles triangle, correct? That means this base angle here will also be theta, because base angles of an isosceles triangle are equal. That means this particular angle will be pi minus 2 theta. The sum of all three angles will be 180 degrees pi. From that I subtract these 2 thetas, so that becomes this angle, and that's what I'm going to write here, sine pi minus 2 theta. Whenever we have pi minus 2 theta, just imagine this way. This is the quadrant, this is pi minus, this is 2 theta. Okay, so in second quadrant sine is positive, isn't it? So no matter what is 2 theta, it will be same as the value of sine pi minus 2 theta will be sine 2 theta, because in second quadrant sine is positive. So I can simplify this as half r square sine 2 theta, because it's in second quadrant. Okay, so this is the area of the triangle. Let's talk about the area of this sector. So area of sector, and let's call it BOC. The formula for the area of a sector is half r square theta, and which will be half, and r for this is r, actual r, theta. This angle is the theta, right? But we know this whole is pi 180 degrees, and this is pi minus 2 theta. So from pi we subtract pi minus 2 theta, we'll get this one, which is again 2 theta. Why? Because if I open this bracket, I get this, pi minus pi is cancelled, 2 theta is the angle, and that's what I will write here, 2 theta. This 2 and this 2 will cancel out, so we get r square theta. So we got the area of this triangle, we got the area of this sector. We'll subtract from the whole semicircle. So let's write the condition they have given us. They have written that the area of the shaded part is 1/3 of area of semicircle, right? So area of the shaded part, first we'll find the area of the semicircle. What is the area of a semicircle? Pi r square divided by 2. This is the area of a semicircle, yes or no? So pi r square over 2, semicircle's area, minus these two areas will give us the shaded area, right? So it will be, so I did not write divided by 2. So we'll subtract r square theta, plus we'll also subtract half r square sine 2 theta. It is 1/3 of semicircle, which is again pi r square over 2. Right? And that's, we have to simplify now. We have to isolate theta. That means this theta is the only theta we have to isolate. So let's take this pi r square over 2 here. So minus r square theta minus half r square sine 2 theta. Yeah, this bracket open, and this is 1/6 pi r square, and this pi r square over 2 will also come here, minus pi r square half. This came here, became negative, right? So let's write here r minus r square theta equal to, I'll bring this one here to the right side, half r square sine 2 theta. Okay, now pi r square, pi r, that's exactly same if I write 1/6 minus half. So I can write this as 3/6. So it becomes minus 2/6. Minus 2/6 pi r square. Okay. So let's divide all three by minus r square, so that I'm left with theta, because they want theta on the left side. divided by minus r square divided by minus r square. This 2 and 6 will also cancel, 1 over 3. Okay, so r square and r square cancel. Theta is equal to r square and r square cancel, but this negative will make it negative. So negative half sine 2 theta. This negative and this negative will become positive, and r square cancels with r square. 1/3 pi plus 1/3 pi, and it is not matching with this. So what will we do? We'll take 1/3 common out of this. Take 1/3 out. So we are left with pi only here, minus, because of this minus, and 1 over 2 divided by 1 over 3. 1 over 2 divided by 1 over 3, which will be 1 over 2 multiplied by 3. 3 divided by 2 is 1.5. Yes, exactly 1.5 sine 2 theta. We have shown what they wanted. Okay, verify by calculation, okay, that theta is lying between 0.5 and 0.7. Okay, so for that, what should we do? This is the one, right? This is what we have. We should move everything to one side. So let me move this part to the left side. So it becomes theta minus 1/3 pi minus 1.5 sine 2 theta equal to 0. Now if I substitute 0.5 and 0.7, because they said equal to 0, if the root is between these two numbers, one of them will give me positive number, one of them will give negative number, so that in between we have 0. And let's substitute one by one. When theta is 0.5, so what do we get? LHS 0.5 minus 1 over 3 pi minus 1.5 sine 2 times 0.5. 2 times 0.5 will be 1. Let's see what it gives us. And second condition, when theta is 0.7, what will we get? LHS left hand side will be 0.7 minus 1 over 3 pi minus 1.5 sine 2 times 0.7, which is 1.4. Let's put these into our calculators and see if one of them is positive, one of them is negative or not. Okay, I got my answer. For this one, I got minus 0.1264, and this came out to be 0.1455. So clearly one is negative, one is positive. That means the root is in between. So we can write change in sign indicates the presence of root between 0.5 and 0.7. Okay, what is next? Use an iterative formula based on the equation in part A to determine theta. Correct to 3 decimal places, okay, and give result of each iteration 5 decimal places. So the equation was theta equal to 1/3. I'll copy this one. 1/3 pi minus 1.5 sine 2 theta. So theta equal to 1/3 pi minus 1.5 sine 2 theta. To make iterative formula, the one on the left, which is isolated, we write it as xn plus 1, and the one which is on inside, it called theta n plus 1 and theta n. Alright, what it means that our starting point, we know that the answer is between 0.5 and 0.7. So let's start from 0.6, which is in middle of them, to get the formula. So we'll theta n, which becomes theta 1, 0.6. That means theta 2 will be 1/3 pi minus 1.5 sine 2 times 0.6. In place of theta n, which is theta 1 now, we will write this and we'll just put this in a calculator and we'll get the answer. What I'm getting here is 0.58118. They said 5 decimal places should be each iteration, so 5 decimal places here. Now similarly, this becomes theta 2 becomes the theta n for theta 3, and we will repeat this process, and I am going to fast forward this video so that you can save some time. And we stop here because they said we want answer up to 3 decimal places. So if we round off this to 3 decimal places, we get 0.588. Here we get 0.586. Here we get 0.587. Here 0.586 and 0.586 again. That means when we have consecutive 2 round offs equal, we stop there. So our answer is that theta is equal to 0.586 to 3 decimal places. Okay, question number 10. It shows us a rational function and says express fx in partial fractions. Okay, and 2 parts are already factored, so it becomes easy for us. 4 minus x plus x square over 1 plus x 2 plus x square. The first thing we should do, look at the degree of the numerator. The degree of numerator is 2. Degree of denominator is x square here, x here, so total 3. So this denominator is more than numerator, so we can straight away start our partial fraction. In case they are equal or the numerator's degree is more, we have to divide first, long division, but not needed here. So we can write here this as a over 1 plus x, which is the first factor, plus bx plus c over 2 plus x square. So that their LCM becomes the same thing, and it becomes 4 minus x plus x square, which is the numerator on the left side, equal to a multiplies with the denominator of the other one, 2 plus x square, and then bx plus c multiplies with the numerator of the other side, which is 1 plus x. First thing first, since we have a linear factor here, we can assume that x is equal to minus 1, so that this part becomes 0. So 4 minus minus 1 plus minus 1 square equal to 2 plus minus 1 square plus 0. This whole thing will become 0 because this is 0 multiplied with bx plus c becomes 0. That is the essence of this, so that we can get the value of a. So 4 minus minus 1 is 4 plus 1, 5. And this will be positive 1, so plus 1 equal to a. Minus 1 square is positive 1, so 2 plus 1 is 3. Divide both sides by 3. So a comes out to be 6 divided by 3, which is 2. Now we have to find the value of b and c. Let's compare constants first, on right hand side and left hand side. On the right hand side, the constant is just 4. This is x squared, so this is the constant. Here a multiplied by 2, a constant multiplied by constant will give us a constant. So 4 will be equal to 2a, and here c is the constant and 1 is the constant. Others have x, so we will not involve them. C times 1 is c. So 4 is 2a plus c. A's value we already know. 4 equal to 2 times 2 plus c. So 4 and 4 cancel. C is actually 0. Now we will compare coefficients of x square. What is the coefficient of x square here? 1. So on left hand side we have 1. Right hand side, a times x square will give us x square. So a is the coefficient. bx times x will give us x square. So b becomes the second x square in this. Others will not give you x square. So 1 equal to a is already known to us, 2 plus b. So 1 minus 2 is equal to b, negative 1 equal to b. So we got b as well. So finally our partial fraction is a, 2 over 1 plus x plus b, not plus, minus, it's minus 1, minus 1 over 2 plus, rather minus 1x, minus x, right? And there is no c, c is equal to 0. So this becomes partial fraction. Okay. Part B, we'll need this one because they're saying find this definite integral of fx, give your answer as single logarithm. Okay. So it will become 0 to 4, 2 over 1 plus x dx minus x over 2 plus x square dx. This is a linear denominator with a constant numerator, so it becomes easy to integrate. It will be 2 remains 2 untouched, but because it is 1 plus x, natural log of 1 plus x. We should also divide it by the differentiation of the linear denominator which we have, but the differentiation of 1 plus x is just 1, so there is no need to divide. Now here, if you see the numerator is degree 1, denominator is degree 2. If I assume, let's assume t equal to 2 plus x square, so dt over dx will be 0 plus 2x, so 2x, right? That means dt will be 2x dx. But we have just x here, no 2. So let's write 2 here and divide by 2 also. So half times 2 is again 1. So just to make it like 2x dx, I did it. So I can write this one as dt, sorry, half was there in front, dt over t. Yeah. And whenever we have dt over t format, I'm not writing 0 and 4 yet. We could have written here, but not in this because t is different. Okay. So let me focus on this one first. So it will become 2 ln 1 plus 4 minus 2 ln 1 plus 0. Now here, minus half, let's take it out, and dt over t is ln t. But t was our creation, let's not use t anymore. We will use its value, 2 plus x square. And now we can write the limit 0 to 4. So let's evaluate the first one first. 2 ln 5 and ln 1 is, this is ln 1, right? Ln 1 is 0, so this is 0. That's it. Minus half. And let's substitute 4 and 0 here as well. Ln, I'm ignoring plus c because it gets cancelled out. 2 plus 4 square minus ln 2 plus 0 square. So I can write this one as ln 5 square minus half ln 18, yeah, 2 plus 16 is 18 minus ln 2. So ln 25 minus half, two natural logs are subtracting, so their contents divide. So ln 25 minus half ln 9, which we can write here ln 25 minus 9 to the power half and natural log 25 over 3 by logarithmic laws, and this is the exact, that's what they said, right? Exact value of this. Give your answer a single logarithm, and we have given it in single logarithm. That concludes our solution video. I hope you liked it. If you did, give it a thumbs up, share with your friends, and subscribe to my channel. I'll make many more videos in coming days. Thank you so much for your attention.